Welcome to Sravz Technical Series. In today's session, we will discuss the historical ticker plant and its implementation. In the Sravz UI, we have a screen where we show historical data for the tickers. They are around 60K assets, for which we do a cross-asset chart display like this. And then we show some summary statistics for those in the UI like this one. So this is based off of Python right now. So we'll start implementation of ticker plant from scratch in Rust and use that for further analysis. Also, Rust provides us a data frame implemented in Rust called Polars. So that is much faster than Python's implementation of Pandas data frame. So we will switch to that. This is the data flow diagram. So this is how the historical ticker plant would look like. We would have an NSQ message server in between. NSQ is a Golang implementation of message queuing system. And then we would have a Rust application which would listen on an NSQ topic, backend-Rust. And then in the front end, we'll have a browser connected via WebSockets. And the Node.js application is connected to backend-node topic. So when the browser sends a message, it is posted to via Rust on backend-Rust topic. So the Rust application will do processing of the data in either Polars or DuckBD using S3 object storage, and then sends the response back on backend-node topic. And the WebSocket will pick the message from backend-node topic and send it back to the browser. So NSQ will act as the queuing system in this framework. So in today's session, I'll do a quick demo of the NSQ and Rust interaction. And in the future sessions, we will implement the complete ticker plant. So I'll switch back to the VS Code. As a quick demo, I'll show the interaction between the queues first. So for example, here I have the Rust application running. We'll go through the Rust application code base in a bit. So now I'll send a message on the NSQ topic called training-rust. And so once I send that message, training-rust, the Rust application will process the message I sent and then sends a response on the training-node topic. And I have a NSQ tail command running on this topic, so I'll cancel out of it, run it again. I have NSQ tail on training-node topic. So once the REST application processes the message, gets us runs the query on the historical data, and that data is sent to training-node topic. Then this is how the WebSocket Node.js server will receive the message, and it will pass this to the client. So for today's session, we'll ignore the message and what's in the message, but the interaction between the Rust and NSQ works, and that is what I'm demoing here. Now I'll go to the code base. This is the code base implemented in Rust. This is the main.rs file where the main function is. We imported a bunch of things that are needed for the application to run. Then we created two topics, the consumer topic called training-rust, which this Rust application will listen on, and producer_topic, which is training-node topic on which the WebSocket server is listening. So the Rust application will receive message on this topic, process the message, and sends the response back on this topic where the WebSocket server is listening. Then we won't go in details on the Rust code base. We'll do that at a later point. So we use Rust NSQ client based on Tokyo. So I started the Tokyo main process here, and then I created an async of main. So it's run off of Tokyo asynchronous framework. Then we created the topics, then created the channel, and then we created an NSQ. This is a MongoDB client. I'll let you know why we need a MongoDB client in a bit. Then this is the NSQD, and look up the address. Then on the consumer topic training-rust topic on which this Rust application has to listen on, we create a consumer and start the consumer. Similarly, we create a producer. The Rust application will produce messages and send messages on the training-node where the WebSocket server is listening on. So we create a producer. Then we start an infinite loop. In the infinite loop, we start consuming messages. And as we consume messages, we get the message in a JSON format. Once we get a message, NSQ guarantees at least once delivery, so it can deliver the same message more than once to multiple Rust clients. So we use MongoDB as a cache here to check if a message has already been processed. If it is processed, we'll send the message which is in the MongoDB. We don't want to reprocess the same message. So that's why we use MongoDB as a cache. And then as a key, we create a hash of the whole JSON message. So we determine if it is the same message by creating a hash of it, and if we have encountered that hash, we'll pick the message from the MongoDB. And then we have the producer.publish. So if a message is already found in MongoDB, we publish that message directly on the producer topic. We don't want to reprocess the message. If not, then we create a hash of the message, and then in the MongoDB, right now we just save the message. In future, we'll process the message and then save it. But for today's session, we're just saving the message. And then on the producer.publish, we publish the message as a JSON string. We decode that message from the Rust structure back into JSON, and then we send it on the producer topic. And then we'll consume the next message. So this is an infinite loop which will continue in a loop. So the models.rs has the message structure we need. This is more for Sravz specific use case, but if you want to extend this, you can use your own message format. In our case, we use this message format. Then there's a MongoDB.rs MongoDB client, in which I implemented a bunch of functions for MongoDB, find by key, update mini, etc. And then we also did test-driven development in this scenario. So I added test cases for MongoDB. So test mongo create will create a document in MongoDB. Test mongo find will find a document in MongoDB. It's more of an integration test, not a unit test. So we need a MongoDB running. I have this MongoDB running in a Docker container. So I use that. And then the test cases. The test cases, if I run, they'll take a while, but if you see here, their test cases pass. Same, test mongo create is successful. Similarly, test mongo find is successful. So that's how we created the NSQ producer consumer in today's session. In the next session, we'll introduce Polars and DuckBD, and we'll fetch our historical data from S3 and then do some processing and send the messages to the client browser. So with that, I'll close today's session. If you have any questions, please reach out in the documentation tab here or in the YouTube channel. Thank you for watching.